Okay guys, today we're going to have a look at a second type of bonding which is called covalent bonding. Now we've already looked and had a video on ionic bonding, and we know that ionic bonding is between a metal and a non-metal. Covalent bonding and then occurs whenever we have two non-metals together. So again, refer to your periodic table before you go and decide what the bonding is. Check that the two things the examiner is asking you to bond come from the non-metal region of the periodic table before you go any further, and if they are both from the non-metal area of the periodic table, well then they will bond covalently. Now, what is the difference between the covalent bonding that we're looking at and the ionic bonding? Well, in ionic bonding the electrons were lost and gained, and we ended up with ions, positive and negatively charged ions. In covalent bonding it's very different because we still try to gain a full outer shell, but this time the way in which the elements or the atoms try to do it is by sharing the electrons. So there's no formation of ions, okay? There's no complete transfer of electrons from one thing to another. So we'll have a look at a few worked examples. What you can do is, once you think you've got this, is pause the video, have a go at them, and then turn the video back on again and check whenever I've done them that your answers are correct. So let's have a look. We'll have a look at the very simple one, the most simple one, first of all, which is hydrogen, which exists as two hydrogen atoms joined together. Now, if we go to the periodic table, we'll see hydrogen has an atomic number of 1, therefore it has 1 electron. Now, in order for hydrogen to get a full outer shell, it doesn't need 8 electrons. It only has the first shell, so it needs to gain 1 more electron from somewhere. Well, we can see here that we have 2 hydrogens together. So, first thing we always do is we just write in our atoms, and we write it in the outer shell electrons only. Don't worry about the others unless the examiner specifically asks for them. So, the golden rule, and this is the rule that you must apply to all of these things, when they bond, each atom in here must give an electron to the bond. So in other words, each hydrogen must give their electron to the bond. Okay, so now let's have a look, and we draw sort of a Venn diagram to show the sharing of the electrons. So this hydrogen here has got a share of those electrons. In other words, it has 2 electrons in its outer shell and has therefore gained a full outer shell. This hydrogen here is also sharing those electrons. It has also got 2 electrons in its outer shell and therefore has a full outer shell. Now let's have a look at what that means. Well, we can draw that shorthand by just one straight line, and that line represents what we call in chemistry a single covalent bond. And the reason why it is single covalent bond is very simply because there is 1 electron from each atom in the bond. And that is the simplest type of bonding that you will get in terms of covalent bonding. Right, let's have a look at another covalent bond. We look this time at chlorine, which is Cl2. Again, chlorine has an atomic number of 17 and therefore has an electron arrangement of that. So let's put our 2 chlorines side by side and let's draw in our outer shell electrons. Note that I'm doing some of them with dots and some of them with crosses, just to differentiate between the electrons from different atoms. Then often you'll see the examiner ask you to draw a dot cross diagram. Again, the golden rule is that you must take 1 from each to begin with, okay, and then we will see. So remember, the common mistake that people make is they take 1 and put it into the bond, but then they forget to remove it from the outer shell, and that leaves them very confused. Let's draw. Well, this chlorine had 6 of its own and now it's sharing those 2. Okay. Our other chlorine again had 6 of its own and it's sharing those 2. Let's check that they have full outer shells. 2, 4, 6, 8. Likewise over here, 2, 4, 6, 8. Okay, so both of those chlorines have got full outer shells now, and they are again single covalent bonds because we have one electron from each chlorine in the bond, and that is diatomic chlorine, Cl2. That's how it bonds. So what we've looked at so far are just simply elements. Now we'll have a little look at a compound. Again, we'll take a nice simple one. We'll take hydrogen fluoride, so HF. So again, hydrogen, atomic number 1, fluorine, atomic number 9, so electron arrangement 1, electron arrangement 2, 7. We'll go down here and we'll draw them in. Okay, so 1, 2, 3, 4, 5, 6, 7, and 1. The golden rule is we always take one from each, we have to. Okay, so remember, get rid of one that is in there, and then we draw our little Venn diagram to show that that hydrogen has access to those two, therefore hydrogen has a full outer shell because it only needs two. This fluorine has access to 2, 4, 6, 8, so it is a full outer shell, and we have hydrogen fluoride, which is a single covalent bond between hydrogen and fluorine. Okay, let's have a look then at another diatomic element. In this instance, we look at oxygen, and oxygen has an atomic number of 8, remember? So it has electron arrangement of 2, 6. So we have two oxygens, so we'll put them side by side, and we will draw in the outer shelled electrons only in each instance. Okay, and therefore we have 6. So again, we will take one from each, and always remember, I know I'm going on about it guys, but it is where students drop marks. We will remove the one that was there originally. Okay, and let's draw our Venn diagram and see how many electrons each oxygen has. Well, we have 1, 2, 3, 4, 5, 6, 7, and the same is true of the this oxygen. So 7 electrons is no good, we need 8. What do? Well, you just keep taking one electron from each until you get a full outer shell. So we take one cross and one cross and one dot. Okay, and again, remember, remove them, and let's have a look at how that leaves us now. So if we count them, we have 1, 2, 3, 4, 5, 6, 7, 8, and the same is true in this oxygen. So this time we have oxygen double covalent bonded to another oxygen. The reason why it's called double covalent bond is because we have 2 electrons from this oxygen and 2 electrons from this oxygen in the bond. Okay, right, let's have a look at nitrogen. And again, nitrogen exists as N2. Nitrogen has atomic number 7, so it's 2, 5. Okay, so again we do what we did earlier. If you're getting used to these now, you can probably just stick in a bond between them to begin with, and that means that each of them have got 4 left. So we'll just do 1, 2, 3, 4, 1, 2, 3, 4. Draw in our Venn diagram to show what has got a share of what. And if we look at it, oxygen or nitrogen have 1, 2, 3, 4. Well, they've only got 6. That's no good. So the rule is that we just simply take another one from each. And when we take another one from each, let's just pop them in there, and that leaves us with 2, 4, 6, 7 electrons in each. No good. Again, we simply remove another one, and then we put that into the bond, and we have got okay, so we have 3 electrons from each nitrogen, and therefore this time we have nitrogen being triply bonded to another nitrogen. Right, let's have a look at a few compounds then. Okay, so the first compound that we will take is we will take some water, H2O. Now, you might say, well, there's a bit of confusion here because we've 2 of one thing and only 1 of the other. This is the rule. If you have a single atom on its own, the oxygen here, you put it in the middle and you take the other atoms, and the hydrogens in this instance, and they must bond to either side of the oxygen. So in other words, let's have a look at the electron arrangement. Hydrogen is 1, oxygen is 2, 6. Okay, so let's just put in our 4 electrons there, and remember I said the oxygen has to bond to the hydrogens on either side. That means it has to take 2 of those 6 electrons, and one of them's got a bond there, one of them's got a bond there. The hydrogen's 1, so it has to put its electron into the bond with the oxygen. Now let's draw in our little Venn diagram again. So we have hydrogen, it has 2 electrons and is obviously happy there. We have hydrogen, again 2 electrons, happy there. And we have oxygen. Well, let's have a look. It's sharing those 2 with that hydrogen, and it's sharing those 2 with that hydrogen. That means the hydrogen is also happy. Okay, so sorry, the oxygen is also happy. So we have oxygen, single bond to hydrogen on one side, single bond to hydrogen on the other side. There is one thing you need to be aware of here, and it is these electrons here. These electrons here are called lone pair electrons. They're used to make the oxygen stable, to get the full number of electrons in the outer shell, 8 in this instance, but they're not used in bonding. These electrons here are called bonded pair electrons. These ones that are not bonded but are used to make up the full outer shell are called lone pair electrons. So just be aware of that name. So applying that to, we'll just go to methane, which is CH4. Okay, and we will take our carbon, which is on its own. Okay, so it has to go in the middle, and there are 1, 2, 3, 4 hydrogens. So carbon has an electron arrangement of 2, 4. Hydrogen, well, we should know that by now, is 1. So we'll just stick the hydrogen electron into the bonds. Remember I said the one in the middle must bond with each of the others that are around it, each of the 4 hydrogens. So the carbon has got to put 1 there, 1 there, 1 there, and 1 there. Now it only has 4 electrons, so that's all its outer electrons gone. Let's again do our Venn diagram. Hydrogen is sharing, 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 and sharing. Let's have a look at our carbon then. Carbon is 1, 2, 3, 4 bonds made, and it has 2, 4, 6, 8 electrons. Therefore it is stable and has bonded. So we have carbon in the middle with 4 covalent bonds around it, and that is our compound called methane. Okay, let's have a look then at ammonia, which is NH3. Okay, again we'll take our nitrogen, and we have 3 hydrogens. Just put them fairly evenly around them. Nitrogen has an electron arrangement of 2, 5. Hydrogen obviously 1. So let's have a look. Again, hydrogen has to put 1 electron in. Nitrogen has to put 1 electron in. Okay, nitrogen originally started off with 5. It's used 3 of those 5. So therefore it must have 2 electrons left over. Well, let's check that and see if that gives us full outer shells. Well, hydrogen is obviously happy because it only needs 2 electrons in its outer shell. Let's have a look at the nitrogen. Well, it's sharing those, it's sharing those, it's sharing those, and it has 2 left over. This is, again, another lone pair of electrons. Okay, nitrogen has 2, 4, 6, 8 electrons. It is happy. We have nitrogen singly bonded to 3 hydrogens in our compound called ammonia. Right, last one then. We're going to have a look at carbon dioxide, CO2. Carbon, okay, is 2, 4. Oxygen is 2, 6. So let's have a look. Oxygen, oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 1, 2. And we'll put 1 in there and 1 in there because they have to bond. Likewise for the oxygen, we'll take 1 out of there, and we'll take 1 out of there, and we'll just pop it in there, and we pop it in there. Let's look at the oxygens. On either side, they have now got 1, 2, 3, 4, 5, 6, 7 electrons only. So they haven't got their full octet. Remove, 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 and then put our O and X and O in there. And now let's have a look at this again. Carbon dioxide, now our carbon has got 2, 4, 6, 8. It's happy. Our oxygen has got 1, 2, 3, 4, 5, 6, 7, 8. And the same is true over here. So our oxygen is happy. Carbon dioxide is 2 double bonds between carbon and oxygen. Okay guys, you can go back over this video and have a look at it, redo those ones that I have just given you. I'll put a couple up here and put the answers up very quickly so you can do them and just check that you got those correct. And hopefully you did. You should recognize the shorthand stuff that I am doing now. That little dots are just the lone pair that are on that. Okay, so go back, do those. If you can do all those, you will be fine in terms of GCSE.